Hello, everyone watching. Welcome to DevFest Enugu 2023. And we'll be looking at an amazing topic today on transforming healthcare in Enugu, early disease detection with TensorFlow. A quick introduction. Who am I? I'm Boniface Emmanuel, chosen a machine learning researcher and engineer at the University of Nigeria, and also the president and founder of Algorithmic Explorer that move individual uh, from who are curious about artificial intelligence to collaboration on different projects around artificial intelligence. I'm passionate about artificial intelligence, which had made me collaborated on different projects, notably a partnership with Hansen Robotics on conscious AI for software robots, and also lead a team of ML engineers from around the world, where I led the deployment team on a project, on a conversational AI project for AI psychologists with human-like memory. Another fun fact about me is that I'm a final year student of the University of Nigeria, also studying computer science. Amazing, right? So, an overview of my presentation will cover the challenges of healthcare in Enugu State, looking at the limitation of traditional diagnostic methods, and prefer a solution through AI-powered disease detection with the development of a convolutional neural network model with 93% accuracy differentiating between infected and uninfected blood cells images. And we're going to look at the impacts on healthcare in Enugu State. So, looking at the context and significance of this topic. If you look at the Enugu healthcare challenges, it ranges from inadequate infrastructures, which include shortage of hospitals, clinics, medical facilities in Enugu State, limited resources that include the lack of access to essential medical equipment, medications, and trained professionals. Another one is high disease burden, and this we have a breakout of or a prevalence of these diseases like malaria, tuberculosis, and HIV. These are high burden disease here in Enugu State. And we'll be looking at the use case. Malaria, we'll be taking malaria as the use case for this presentation. So, according to World Health Organization, 10% of Enugu population have malaria in 2023. That's a huge number. So, what role does AI then plays in this sector? That is healthcare per se. Improve diagnostic accuracy. With the AI-powered algorithm, it can actually help to detect or help in early disease detection and also improve diagnostic accuracy. And also in the case of efficient medical images, it's assisting radiologists in detecting anomalies using AI to analyze medical images, which is amazing too. And also in predictive analytics, AI application can actually predict the disease outbreak and help allocate resources effectively. So what does this mean for us? I mean, disease detection, the importance, and the AI benefit. Remember, early detection saves lives. So with a good AI-powered platform to actually help you save, to help detect um, those diseases, a lot of life will be saved. And it can also help to even increase our life expectancy. That would be a good one. Rapid screening. Due to the high number of people who actually need health, these services of our radiologists and other healthcare professionals, um, As I even talked about, I don't know the number of people who actually use this healthcare centers, but the number is outrageous. So with this number, I think with rapid screening, we could be able to cater for this number of people who actually have the disease, and with reduced human error, whereby we're going to do this without stress. So we'll be looking at this use case, the project per se, the malaria detection project. And we're going to be following this pipeline from data collection to model evaluation. And in the process, it involved preprocessing of data and model building. So the malaria data set was actually collected from Lister Hill National Center for Biomedical Communication of the National Library of Medicine, which has over 27,000 images. And as you can see from these images here, we can be able to see a clear distinction between the uninfected cells and the infected cell. Now, for the libraries used, we actually leveraged on TensorFlow. A lot of us who are curious to know what TensorFlow is. So TensorFlow is an open source machine learning library developed by Google that is used to build and train machine learning models. So it allowed developers like us to create, design, train various types of neural networks, including deep learning models like convolutional neural networks or recurrent neural networks, which is amazing. And it's also known for its scalability, flexibility, and ability to handle large machine learning tasks, which is something amazing. And we can leverage on to improve healthcare here in Enugu State. So these are all the libraries we actually explored, from TensorFlow to NumPy to Matplotlib to all those libraries. OS, which is used to access different directories through which we get our images from. So having said that, we built a model, but this is the actual structure of our model here. That this is our convolutional neural networks, and our convolutional neural network had this convolutional layers and a pooling layer, which is used to downsize the images and to focus on the more important parts. And also, it also has dropouts to remove some connection between the neuron to actually prevent overfitting. So just like practicing problems from different textbooks instead of just relying on one textbook. That's just what it just means. So we added more layers and apply flattening to actually turn the 3D shape into a straight line, that is a single array. So doing that, we have fully connected layers of 64 neural network, 64 neurons, sorry, and using ReLU as the activation function. Then dropout being applied again, and our output layer, as you can see, which is just one neuron. We are just either detecting either a patient has malaria or doesn't have malaria, or that the image has what are you calling it? The red blood cell is infected or not infected. We'll be leveraging on the activation function called sigmoid, which squashes the value between just zeros and one. That is one amazing thing about this function. So this is the model on which data set was actually trained on, and it achieved a model accuracy of 93% in the process of detection, which is a good one. So looking at the real life application of this model, that is This is moving it from the notebook to a web-based application, which is the malaria detection app. So in building this application, the technologies involved include the Python, TensorFlow, Keras, Streamlit, and NumPy. Having these functionalities of file upload, image processing, then training it on the machine learning model, and then boom, displaying the result. So if you look at the code for the deployment, in the process of deployment, we actually imported Streamlit, TensorFlow, and NumPy, did some pre-processing in the process, that is creating a function to do the pre-processing when after collecting the file, that is the image itself, to help us to return whether malaria is detected or not detected. Now in the process of creating the UI, this is well commented. So for the malaria detection app, we upload the images, and the images we upload could be JPG or PNG, which after calling the function, boom, it produced the result for us. Good and amazing. So as you can see here, it's a live demo of the application. Although you may not be able to see me as I'm actually trying to view the files. In the process of trying to do this, I don't know, my camera wasn't able to capture this, but just take it this way. It's going to actually show you where I actually uploaded the file. As you can see here, it has been uploaded, and after it is uploaded, boom, it detected malaria, which is true from what we have so far. So how does this impact, how does it have an impact on healthcare in Enugu State? Looking at the business implication, looking from the standpoint of business implication, partnership with healthcare organization will be very crucial in this state, because partnering with healthcare organization will help test this model to improve this diagnostics of malaria patients here in Enugu State, and integration into healthcare system, existing healthcare system. We could have sites already existing that have these data sets. So using this model as an API there to actually help the differentiate between the variations of the disease, it's germane, and it could also be a potential revenue stream through subscription or any other means. So it's amazing. It's amazing. So looking at the future enhancement of this project, which is a challenge to every one of us actually listening, we could take this as a challenge. We can actually improve what has been done already. Incorporating additional diseases, and I told you in Enugu State, we not just malaria, we also have HIV and AIDS, which will be amazing because a lot of us would not like to take tests. So this is an avenue for us to actually have some personalized healthcare system working for us. Expanding this reach by reaching out to not just the people in town, but also the locals to actually make use of this application and also improve the accuracy. Since we're dealing with healthcare, we need to achieve something which is close to 100%, which will be amazing. So this is something we should look into the future. So for future redirections and the challenges we are going to be facing. So looking at the challenges first of all, the challenges we could actually face in this process is data privacy and securities, regulatory concerns, and accepted by healthcare professionals. Some healthcare professionals could shy away from using this product, which will actually help them. The truth is that it's not going to replace you, but it's going to help you make you work more efficient. Right, and leverage on an AI-powered detection tool is going to help you out. So from what I said so far, domain knowledge is actually very important. Therefore, everybody plays a role here. Whether you're an AI expert or not, you plays a role here. Now, a call to action. With this quote, I actually read it up here, that AI holds the power to revolutionize healthcare by improving diagnostics, treatment, and patient outcome. Collaborations among healthcare professionals, technologies, policymakers, and researchers is key. Let's use AI to reshape healthcare for a better and more inclusive future. Thank you all for listening to me towards the time, and I'm grateful. So, if you have any question to ask me, you could hit me up via my social media handles. You can check me out on YouTube, Boniface Emmanuel Choosing, on Twitter at Boniface Choosing, on LinkedIn, Boniface Emmanuel Boniface. So if you have any question, hit me up. Let's connect.